morning everyone. In previous class, we discussed about laws of motion. Basing on laws of motion, we discussed about types of motion as well as Newton's laws of motion, first law, second law, as well as third law. Basing on those lab activity, which means activities basing on Newton's laws of first law of motion, second law of motion, we already discussed. Basing on those concepts, activities also completed. On that, examples also completed. Okay, today we will go on with Newton's second law of motion, which is already discussed. Basing on that, we will discuss few examples by from Newton's second law of motion, which is very important for further classes. Okay, which is very important for further classes. That one is example 3. Up to we discussed about example 2. Okay, up to we discussed about example 2, which came 1 by 2 Newton. Okay, how many of you remember? I don't know, but it came 1 by 2 Newton of Newton force is acting on that object. We discussed, which means we proved 1 by 2 Newton. Okay, today example 3, and this example 3 is basing about Atwood mission. Okay, Atwood mission. Okay, Atwood mission. This Atwood mission is used to prove the Newton's laws of motion. Okay, this Atwood mission is used to prove the Newton's laws of motion. How it is there means, we are consider two masses. Consider two masses of m1 and m2. Consider two masses of m1 and m2. These two masses are connected to pulley. Okay, these two masses are connected to pulley. How it will be? This will be like this. This is the pulley, and this is mass m1, and this is mass m2. m1, m2. What's happening here? What happened here? Pulley. If m1 is greater than m2, then this object will move downwards. Okay. If m2 greater than m1, which means then this object tries to move this object downwards. Okay, this is case 2, case 1, case 2. Okay, case 1, case 2. This is case 2. This is case 1. Okay, this is case 2. In case 1, it will move upwards. In case 3, if third one is m2 equal to m1, then what will happen? Both will be balanced equally. Okay, both will be balanced equally, which means both masses are equal, then masses will be balanced. Okay, basing on this, we have one problem. Basing on this, we have one problem. This is about Atwood mission and 3 cases. So problem is, the string runs over a pulley. Find the acceleration. Of each load. Find the acceleration of each load and tension load and tension in the string is M1 greater than M2, if M1 greater than M2, then how it we are working. Okay, so solution will be like this. For M1, this is for M1, tension will act upwards. Okay, tension will act upwards, as well as M1G, which means mass into gravitational force. Okay, and acceleration will try to act downwards. This is for mass M1. And if we draw for M2, which means from this, if we draw free body diagram for M1, then what happens? M1 F net, okay, force, net force is equal to M1 into acceleration M1A. Okay, so this we can take it as M1G equal to M1G minus tension. F naught means this M1G as well as tension, all these if we remove, minus is equal to M1A. So this is, if we consider this one as a equation 1. Now write for M2. Okay, this is for M1. Now write for M2. Same, but here we need to remember this one. M1 is greater than M2. Okay, this is M2, object M2, and this is M2G. This is M2G, as well as tension will act upwards, as well as acceleration will act upwards. Now if we draw free body diagram for M2, FBD for M2, then F net equal to T minus mg, means M2G, okay, equal to T minus M2G equal to, that implies T minus M2G equal to M2A. Okay, this is the equation number 2. Okay, just write the equation 1 and 2 at the same. Now what is equation 1? M1G minus T equal to M1A. This is equation 1. Okay, and M2G minus T equal to M2A. This is equation 2. Now from equation 1 and 2, by solving equation 1 and 2, we will get A equal to M1 minus M2 by M1 plus M2 into G. Okay, like this we will get. Okay, M1 minus M2, which means we are bringing A this side. Okay, next one, from this equation only we write for tension. First of all, if we write for acceleration, I will write it here, just don't worry. By solving equation 1 and 2, we will get, so just add the equation, positive minus plus. Okay, so we need to find the acceleration. Tension will get cancelled, then what will happen? M1G minus M1A and M2G minus M2A. Okay, this will become plus. Okay, now if we write both the equations same side like this, if we write both the equations same side, then M1G minus M1A equal to m2g plus m2a. It will be minus only. Okay. Now bring this equation this side. Take common a. So m1a plus m2a by m1 equal to, we will write this m1g minus plus m2g. Okay, now take a outside, bring this equation this side. What will happen? m1 minus m2 by m1 plus m2 into g. Okay, this will be the equation. Okay, now if we write equation for tension, by solving these two equations only, if we write equation for tension, then what will happen? Tension will be added. So T equal to 2m1 m2 into g by m1 plus m2. That's it. Okay, this will be the tension equation, and acceleration equation will be A equal to m1 minus m2 into g by m1 plus m2. That is equation 2. Okay, this is about tension as well as that is about acceleration. Next one is third law of motion. Basic third law of motion. Next one is about Newton's third law of motion. Okay, Newton's third law of motion. So we already know about Newton's third law of motion. What is meant by third law of motion? For every action, there is a equivalent opposite reaction. Okay, opposite reaction. Now, for basing on this Newton's third law of motion, we are deriving activity number 6. Activity 6, basing on this Newton's third law of motion, which means pulling two spring balance. Pulling two spring balance, which means if we consider it two spring balances, okay, this is spring balance 1, okay, and this is spring balance 2, this is spring balance 2. We are trying to pull the spring balance equally with equal force. Okay, we are trying to pull. We are trying to pull spring balance with equal force and leave the spring balance after some time. What will happen? With how much force it went backside, again those two will come towards the forces. This one is known as acting spring balance. Now action reaction forces. Okay, basing on this only, action reaction forces, if we write few what is that so basing on this activity only, if we write few conditions basing on this activity 6, then what will happen? We apply, we notice that there will be a action reaction force. Action reaction force. Okay, action reaction force, which will, for example, if we take a small object or small ball, this is FAB, this is F net, or we can take it as FBA. Okay, object A, and a large object of force FAB, which is object B. Okay, so from this, if we take FAB equal to FBA, this is about action reaction forces. This is about action reaction forces. Okay, so if we write like this, O will be plus. If we write these two like this, then equal to FAB equal to minus of FBA. Okay, minus of FBA. This is about Newton's law of motion. We already discussed about motion of the rocket. Okay, motion of the rocket, which I have, I already told you, when rocket force or fuel force acting downwards in this direction, which means force acting in this direction, then action will take in opposite direction. Okay, force acting in downward direction, then action will take in opposite direction. This is about Newton's law of motion as well as Atwood mission. Okay, basing on all this. Okay, in next activity we will conclude with remaining activities, which means the balloon rocket and small activity basing on action reaction forces and conservation of forces, and next one is dropping egg on the floor. All this we will discuss in next class, and just go through with Newton's laws of motion. Okay, and basing on this laws of motion and activities also. Okay, thank you everyone.